Let's solve the problem. A ball player catches a ball 3.4 seconds after throwing it vertically upward. With what speed did he throw it and what heights did it reach? Here we have two questions in one problem. So basically this is two problems, maybe independent, maybe not, packed in one. If you have multi-part problem, you have to solve each part separately. So let's start trying to find the speed with which ball was thrown vertically upward. So again, you have to start from the harvesting of numerical information, and the only data given to us is 3.4 seconds. This is the time of the flight from initial to final position, 3.4 seconds. Clearly this is delta t. Now, because in this case we have vertical motion, clearly we have to deal with the gravity acceleration. This is hidden piece of the numerical information which is not directly indicated in the condition of the problem, but you have to take this into account. Your acceleration would be 9.8 meter per second square. Keep in mind that we did not assign any direction of the axis yet, so we cannot talk about positive or negative acceleration. The only what we can claim that is acceleration is directed downward. Now picture, you have initial point, you throw your ball which goes upward and then return back. So you have initial velocity directed upward, and this is your unknown quantity. Then ball reaches highest point and return backward, and in your case initial point coincides with the final point. You have gravity acceleration, and this gravity acceleration 9.8 meter per second square directed downward. This is our picture. Now, to be able to assign coordinates to initial and final point, we have to pick up axis. I will put axis along the motion, and I will pick up axis x, let's say upward. In this case, our velocity will be positive. If you want, you can just mark this. And acceleration will be negative, so you have to assign sign minus to your acceleration. Again, you can do this only after you pick up axis of motion. We have to put origin somewhere. I will put origin at the initial and final point. In this case, x initial would be the same as x final, would be equal to 0. And we have x initial, we have x final, we have acceleration, we have time. We need to find v initial. If you look at three formulas, only one formula does have all of these quantities. This formula looks like x final equal x initial plus v initial delta t plus 1/2 a delta t square. If you put in this formula your data, you'll have 0 equals 0 plus unknown v initial times 3.4 seconds minus 1/2 9.8 meter per second square times 3.4 seconds squared. Solving this equation for the v initial, you can find the value of the speed with which you throw your ball. If you will solve correctly, you will have 17 meter per second. So we did solve first part of the problem. Now second part of the problem. Second part of the problem has nothing to do with the first part, so I have to redraw a picture. I have initial point, I have v initial. Now I know numerical value for the v initial, 17 meters per second, and my ball travels upward to the highest point which I have to find. So this is my final point for the second part of the problem. This final point is different than it was in the first part of the problem. And again, I have gravity acceleration. If I will use the same axis x directed upward, the same origin, I will have negative gravity acceleration minus 9.8 meter per second square. And my x initial will be equal to 0. X final I have to find. Look, I do not have time anymore because delta t is not time to travel from initial to final point. This is a time to travel from initial again back to initial point. But I have one more quantity which I know. I know that the highest point will be highest because the ball will not be able to travel higher than this point. So x final will be point where final velocity will be equal to 0. Otherwise, ball will continue to move upward. So now I have x initial, v final, acceleration. I'm looking for the x final. If you look at the formulas from the formula sheet given to you, the easiest way to solve this problem is to use third formula. X final equal x initial plus v final square minus v initial square divided by 2a. If you put data in this formula, you will have x final equals 0 plus 0 square minus 17 meter per second squared divided by minus 2 times 9.8 meter per second square. If you will do calculations properly, you will have 14 meters. We solve second part of the problem.